Okay, this is Year 12 Mechanics 1 Chapter 2. I'm going through question 3 from your assessment paper. So we have two cars A and B move on a parallel straight horizontal track. Initially A and B are both on rest, and at time t equals 0 seconds, A starts to move with constant acceleration for 3.5 seconds, reaching a speed of 14. So I would like to find, first of all, the acceleration. So I'm going to find acceleration. To find acceleration, I do know acceleration is the change in velocity over the time taken. So acceleration is the change in velocity. The final velocity reached is 14, started from rest, initial velocity is 0, 3.5 seconds. So therefore acceleration must be 4 meters seconds minus 2. We have the acceleration. Now for part B, we would like to sketch a diagram, a distance time, a speed time graph. So to sketch a speed time graph, we are going now to sketch this using ruler, and I'm going to start with the axis. And therefore I have here the time in seconds, I have the velocity in meter seconds minus 1, and as we do know about car A, it started from rest and is moving with a speed initial final velocity of 14 and for 3.5 seconds. So if I'm going to sketch first of all car A, let's say this is our car A, and is gonna reach a velocity of 14 for therefore for 3.5 seconds, and then is moving with, as we know, at time t seconds, reaching a speed, the car moves with constant speed of 14, then it's moving with a constant speed of 14. So if I'm going to draw that constant speed of 14, car B also starts from the time t equals 0 in the same direction as car A. Car B moves with constant acceleration of 3 meters seconds minus 2. At time t equal t seconds, B overtake A. At this instant, A is moving with constant speed. So let's sketch on our diagram car B. Okay, so we know this is our car A and this is our car B. At time equal t seconds, they overtake each other. So this is our speed time graph on the same axis. For part B, we would like to find the value of t. So first of all, to find the value of t for part C, to find the value of t, I'm going to look at area under A. So area under A. So I'm going to consider I have a triangle and a rectangle. So this is the total time taken here, which I know this is t. So area under A must be the area of the triangle, which is the half times 3.5 times 14, and the area of the rectangle, which is t minus 3.5 multiplied by the height, which is 14. So if I'm going to simplify, this is going to give us 14t minus 24.5. Okay, we do have the area under A, but we also know for car B moves with constant acceleration of 3 meters seconds minus 2. So we would like basically to find here what's going to be this velocity for car B that is going to reach this velocity. So if I do know for car B now that is acceleration is going to be a change in velocity over the time taken. So I know it's change in velocity over time taken. So the time is t, so I have final velocity minus initial velocity is going to be 0. The time is t seconds and acceleration, as I know, is equal to 3. So therefore our velocity must be 3t in this case. So as I know it's going to reach a velocity 3t in here, can I now work out the area under graph B? So area under B in here must be the area of the triangle. So the area of the triangle must be half times t times 3t, which is 3 over 2t squared. Now area under the two graphs, they must be equal. So if I'm going to equal the area under A must be equal to the area under graph B. So I'm going to equal 3t squared over 2 equal to 14t minus 24.5. So if I'm going to multiply all by 2, I get 3t squared. And I'm going to rearrange minus 28t and plus 49, make this equal to 0. I have a quadratic, I can use the quadratic formula or I can factorize. If I do use the quadratic formula, I get the time as equal to 7 seconds, and I do get the time as equal to 7 over 3. But I do know the time must be greater than 3.5 seconds. So the accepted value of my time, it must be 7 seconds, it's our accepted time. For part D, can we find the distance now that car B, the distance of car B from the point Q when B overtakes A? So if I would like to find the distance for part D, I'm going to work out the area under graph A or B, area under B, therefore, which it must be half times 7 times 3 times 7, which is going to give us 735 meters. Okay, I think this is where you had a difficulty. Thank you.